Salmon are the lifeblood of BC's coastal rainforests. They are a staple food for many people, animals, and the forest itself. When they make their final long journey up freshwater streams, they die after spawning, returning important nutrients to the soil and their local ecosystem. Did you know there are over 9,000 distinct spawning populations of salmon in BC? And approximately half of them are under threat or in decline. The first step in protecting and restoring these salmon populations is proper monitoring and counting of them. We're fish-CenS, a team of BCIT engineers looking to solve many of the shortcomings with current salmon monitoring techniques. Currently, researchers count spawning salmon in 3 ways. On major rivers, such as the Fraser, researchers use expensive sonar systems to detect salmon as they swim past. This is great for low visibility and larger rivers, but it is extremely expensive and it doesn't give you information on the individual spawning population's health. Also, there's no way for the sonar to determine which type of salmon it is detecting or even what type of fish it is. Alternatively, they will build large structures in rivers, forcing salmon to swim through a narrow gate where they can photograph or take videos of the fish. This gives more information than the sonar, but currently they still rely on researchers reviewing the footage to count and identify the fish. Also, building these structures into the rivers can be quite damaging to the very ecosystems they are trying to monitor and protect. Finally, researchers will sometimes actually walk up spawning streams and manually count the salmon they pass along the way. This is great for determining the health of individual spawning populations, but it is quite time-consuming and takes a lot of expertise. That is why we have built a non-intrusive, deployable camera system to record and count fish. Our device uses a machine learning model to recognize salmon in the frame. It then uses a tracking algorithm to monitor those fish and count how many swim in each direction. It can run continuously off a 50-watt solar panel and includes onboard temperature and depth sensors to monitor the conditions of the creek that are important to researchers. Our device can be used in any remote stream to monitor the health of individual spawning populations of salmon. It has a small footprint and no permanent structures need to be built for it, making it minimally impactful to its environment. We reached out to our local hatcheries who are excited about our project and allowed us to place our device in their tanks to test on real salmon. Here you see our device drawing a purple box around objects it believes to be a salmon, then a smaller green box around the center of mass, which it will then track. When the green box passes the center line, one of the 2 fish moving counts will increment depending on the direction of travel. With our device, we hope researchers will more efficiently and cost-effectively be able to monitor the health of individual spawning populations of salmon in BC. Thank you very much.